Hi, everyone. So I was asked, one question was clarified to me and the other one was brought up. So I'll address this in case anybody else had those questions. I was asked, clarified between the red and the blue and the dots. What did that mean? So I could hover it so you can see. If you hover over the blue, come on. Not the circle. It's just that one is better than the other. So you have when the sample quality, it's valid and it's okay, meaning that it's not, that it's still good, but it's not great. And if you hover over the blue, then you get okay, but it's even better. But both of them, you're still in good shape. The other question I was asked was, if I have SSM values of 3.75 and below in all my parameters, would that be a good panel? The answer is that it is an indication you have a good compensation panel. It does not guarantee you have a good compensation panel, because SSM, the one thing it doesn't take into account is spread. So that is currently being worked on in the community, in the Flow community, to design a new matrix that takes into account all the parameters SSM does, plus the spread. Yes, Howie?
I'm not sure which version of FlowJo you're on, but it doesn't cover the brightness, right? And the brightness is, we have a new matrix called the TSM. That's when you click on the button, and that removes the brightness aspect of it. And so you are getting a true spread value.
Okay, so Howie is letting me know that there's a new version of FlowJo that actually it is taking into account brightness. So if you remember, brightness is what causes it. If I said if it's too bright, it's going to increase your spread. So that will go ahead and start taking into account your spread. So I would say you need to consider all those aspects when you're designing your panel, because like I said before, if you have too high of spread, you might be considering that something is positive when in reality it's negative. Well, not really a positive, but more like a dim positive. All right, so let's move on. Let's start the next part with QC. After I finish QC, we're going to go ahead and cover keywords and then groups. So QC, how do you run this? I would recommend you go to our FlowJo website. Here, go to the main website. Click on FlowJo Exchange, which is where we keep all of our plugins. And plugins are just an extra piece of software that enables new features in a software. So here, look for, unclick SeatGeek, so we just get the FlowJo. And here we're going to go ahead and look for Flow AI. Flow AI is going to, again, look at your data and basically clean it up for you. That way you don't have to worry about it. You click on the download button here, you install it into your computer, and then you run it. I'm not gonna go over how to install plugins today because that's not what the session's about. But again, if you wanna install them, I need help. Well, there's your core. There's also Howie here, he could help you today, and Veronica can also help you. Okay, so, and again, I would highly encourage you to download it and to run it, because again, most journals are now looking for clean data. It's not like the old days that you just submitted flow data and people were like, okay, then that's fine. All right, so I'm gonna select a sample at random. The next thing I'm gonna do is click on workspace, and where it has the button that says plugins, click on it. It's gonna show you all your plugins. I'm gonna click on Flow AI. It's just gonna ask me to save it, I'll say fine. Select all your your non-compensated parameters, like so, including time. And then it's gonna say all checks. So what Flow AI does, it checks 3 different things. It will check your flow rate and signal acquisition. And it's also going to check your dynamic range. Okay, so it checks for 3 things in your data. So select the all checks. Where it says second fraction FR is basically how often does it analyze your data. We have it at 0.1. That means at a 10th of every second of sample acquisition is your data analyzed for quality. Okay, and then click on remove outliers. On dynamic range, make sure it says both, because you want to look at the upper and lower range. Please do not move any of these tunables, because this is what the published is associated with. So if you go ahead and submit to a journal and you said, I use FlowAI to clean my data, but you changed the tunables, then you're going to have to explain why you changed the tunables. Essentially, you'll have to explain why your data is not good enough to pass under stringent conditions. And that's not something you want to get into. All right, and if you want to look at the paper, the citation is listed here, Monaco et al. And then click on OK. FlowAI will run maybe about, I don't know, a minute or two, maybe even less, depends on the sample. This is 262 events, looking at something like 12 colors. And there we're done. And now it gives you FlowAI bad events and FlowAI good events. Make your life a lot easier rather than you having to think where your good and where your bad events are. Click on FlowAI good events and start your analysis. That simple. Now, if you want to see what that really looks like, you could go to your derivatives folder. So if you call FlowJo for help regarding one of your plugins, the first thing they're going to ask you is, please go to your derivatives folder. What does that mean? So if whenever you run any plugin, it's going to send data to this folder. So here it is. Wherever you see your workspace is where your derivatives folder is going to go. And then the plugin will be labeled there like FlowAI. Double click that. And then it's going to show you a figure for what your data, what was done to your data. And again, if you need this for record keeping purposes, just have this on hand. The top part is looking at your dynamic range, what was removed. And then the middle graph is flow rate and showing you what was removed. If you see here, I zoom in, you have a little green circle. That's the amount of events that were, those are the events that were removed. Sorry. Sorry, the mic died. So the little green circle is the events that were removed due to a change in flow rate. Why would events be removed in flow rate? If you change the rate at which you're doing your acquisition, or there was a problem of events, meaning a clog or a spike because, again, there was a clog and then too many ran through, etc. One thing I would also recommend when you're running your samples, do not change the flow rate mid-acquisition. Whatever you run your controls with is what you're supposed to run your samples with. Also, do not run your samples on high unless you're working on a sorter and you need your cells really, really fast. It lowers your quality. However, you get probably higher viability. But with an analyzer, keep it at medium or low if you're working with a BD instrument. If you're working with another manufacturer, speak to them, but never run it at the equivalent of a fast BD cytometer. Because what happens is that you're running multiple cells simultaneously. They're going through the acquisition. And when it's running too fast, you might have two cells, and then the signal that is detecting your emissions is getting partially one, partially the other. So you're not getting accurate data. Okay, so don't run it on fast. All right, so the next part is down here, which is your signal acquisition, which is the one we were looking at under the metadata. So this is another figure for that. So it's doing all these analyses on your behalf very quickly. That way you know what's good and what's bad. Okay, so now that we cover sample quality, And like I said, you just double click your FlowJo good events, and here you start with your doublets. All right. All right, so let me delete this for a second because I'm only doing this for the demo. All right, now that we covered that, let's move on to keywords. Keywords are going to be highly important for your annotation purposes. Why? If you leave the data, if you leave the lab or you go on vacation or something and you come back, you may not remember what you're looking at. So this is one way to do that, or for your colleagues to also know what they're looking at. If you submit to a journal, you want them to be able to look at data and know exactly what they're looking at, rather than having to email you back and be like, what am I looking at? So how do you do this? Right click on the column and then edit column. If you added keywords during acquisition, you could add them here. So let's say STEM condition. Now, why is there an asterisk? Because FlowJo will organize these based on types, and then there's a sub-organization based on alphabetical order. So it can be kind of hard to find them. Also, if you come back 6 months from now, 2 years from now, you're not going to remember what were my custom keywords. So if you put an asterisk on it, you know exactly these are custom keywords. Again, when you submit for publication, you could say custom keywords are prefaced with an asterisk. Very simple. You click then on add column and click on OK. That's going to bring in the stimulation keyword. There's a question. Okay. Then these, what is this keywords? PI is for PMA, and then I is for ionomycin. It's a stimulation, is 2 compounds that we use for stimulating cells, PMA, ionomycin. NS means no stimulation. So this, let me tell you a little bit of background about this experiment. This is an HIV experiment where the question being asked is, do cells behave differently when stimulated with PMA ionomycin at 2 different time points or none at all? And how are we measuring differences? We are measuring it based on cell activation, degranulation, phosphorylation, and activation, phosphorylation, and degranulation part. So 3 things. And there's a question. Okay, there's another, okay. And then, all right, so what about if you want to add your own keywords after you ran Flow? I normally used to add on myself afterwards because I didn't have that much time in the machine, right? We all have limited time on the analyzers. So what you can do is click on workspace, then click on add keyword. So let's say I'm going to put here vaccination, and I click OK. It's going to create a new column called vaccination. Here, you can start labeling your samples as vaccinated and do the drop down, placebo, and non-vaccinated, if you're doing that type of study. Alternatively, if you have too many samples, what you can do is select one of the samples, then click on create keyword value series, click on their keywords, label it here as one of those 3. After you do that, say you want this to repeat every 3. So now you see the pattern, right? Vaccinated, placebo, non-vaccinated, vaccinated, placebo, non-vaccinated. So whatever your series is. You do that, click on OK, it's going to fill it out for you. You could also do a series of 1, 2, 3, etc. And then you could tell FlowJo to auto-calculate that. Works very similar to Excel. Now that brings me to the point of Excel. If you have keywords in Excel, rather than typing everything over, copy the cells in Excel and then just paste them into FlowJo. FlowJo will recognize these and then just add your keywords. I would recommend that you have your workspace annotated as you have your lab notebook. So that way you're able to also, if you go into high dimensional analysis, then you're able to compare data on non-conventional parameters. So what do I mean with that? Let's say you want to compare how do your phenotypes differ between treated and untreated. You could do that analysis now. You don't just have to ask for phenotypes. Or if you want to ask, how do I compare between my 3 different days, day 0, 1, and 2, and do an additional analysis of vaccinated and non-vaccinated per se. So you could do those 2 non-conventional, incorporate them into your high dimensional analysis. And I'm going to talk about that tomorrow. Okay, so if you want to come back tomorrow and learn how to do analysis with non-conventional data, incorporate it into your conventional data, then that'll be covered tomorrow. So this is why this is also really good for tomorrow. All right, moving on. We talked about keywords. Now let's talk about groups. You could also then click on a keyword and click on create a copy value to group, pardon. I'm sorry, create group from keyword value. So here, again, it organizes your data very quickly, because if you add a keyword, now you can see here that it has a group for non-vaccinated, placebo, and vaccinated with the appropriate samples in there. Now you've organized your data very quickly and labeled it where you could do conventional or you could do high parameter analysis much more easily. All right, let's also look now at how to create groups manually. You create a group by clicking on workspace, then click on create group. Here, just go ahead and label it. I'm gonna call this a double stem. Here, then click under keyword, under my stem keyword, and I'm gonna say that it contains, and under choose, I'm gonna click the sub keyword, right? Because the header is your main keyword, and anything that is in a row would be a sub keyword. So I'm gonna click on PIPI because that's the double stimulated at 2 different time points. And then I'm gonna click under more choices if I wanna make it more restrictive. And now I'm gonna change it from a keyword to a file name, right? To just mix it up a bit. So file name, URI, and I'm gonna say that it lacks. If I click here, I'm gonna get a list of all my file names. Again, naming matters. So if you label all your FMOs per se as FMO, as I have it here, you can see here my controls, FMOs. If you label everything the same, it's very easy to organize your data. So what I'm gonna say here, exclude anything that is that has the word FMO on it. Again, it has to be exactly how you have it here, okay? So we do that, and I'm gonna click on create group. What do you see now? It brought in my experimentals that are double stimulated and excluded my FMOs. Because I had obviously controls for double stimulated, single stimulated, and non-stimulated. Now, what are FMOs? FMOs are fluorescence -1. And these are that you include all your parameters in your sample that you're running, your acquisition, but you're leaving out one color. So let's say you had 4 colors, right, in total: APC, PE, FITC, APC, PE, and APC. FITC, PE, APC. I say 3 colors to make it easy. Your FITC FMO would only have PE and APC. It will lack FITC. So you need an FMO for each single one of your parameters. Please do not use isotypes. Isotypes are not legit. There's already enough papers saying that. If you have questions with your PIs, because some PIs will still say, hey, where's your isotype? That's not a thing. You could, if you like, I could email Dottie the articles that have been published even recently, because it's still, for some reason, an argument that showing that isotypes are not good controls. They're only appropriate if your antibody was self-conjugated. So if you conjugate it in your own lab. But if they're validated by a manufacturer, you don't need an isotype. Then you use your FMOs to set your gates. Okay? All right, moving on. How do I create a group and add samples manually? So I'm just going to label this as demo. I'm not going to do anything else to it. So it creates a group, but nothing on there. So what I could do is go to all samples, and I could also organize my data here. So I'm going to go under stim, actually under name. Yes, under name. And I'm going to grab, let's say, all subject 12. Highlight them, click, drag, and drop onto the demo, and it brings out 4 samples. You'll see under size, it has 4 because 4 samples are added to that group. So I've shown you on groups how to create groups 3 different ways. One would be from your keywords. Another one would be creating groups, but making it restrictive so it only adds the samples you need. Or 3, how to add samples manually. Okay. All right, now that we covered that, let's move on to the next item of business, because now we cover QC. And we basically cover data organization and management. Now let's go into the actual analysis. So why don't I open up one of my files, let's say the double stim, and let's presume I already ran Flow AI on all 4 samples, okay? What I first want to do is look at my doublets and singlets. What are doublets and singlets? Singlets are, as you can imagine, single cells that you are the accurate for analysis. So here I'm going to click on a polygon gate. This goes on a 90-degree angle most of the time. Cover them. And you'll notice I made this a little wide. Why? Because activated monocytes tend to have like this little arching that is next to lymphocytes that is normally found right here. And you can see a little bit right there, like right here. All right, so I'm going to double click that. Then I'm going to create my forward side scatter gate. And now you can see that when I did an exclusion of singlets, just by doing that little level of QC, and let me revert back, oops, just so you can see how messy it was versus what it looks like now. On the left, you have non-removal of doublets. On the right, we have the doublets removed. You can see that it's very difficult to tell where the granulocytes start and end from this area where you would find the majority of the lymphocytes. You also see this huge population on the far right, and you see a lot of events on the edges. When I just did a very quick QC, there's nothing on my edges. That population on the far right mostly disappeared, and the different separation between these 2 populations is now clear. Okay, so just doing a little bit of QC, you can see how much the data is different. So if you could imagine if I ran actually Flow AI on this and did a doublet exclusion, then this data would be super clean. And that's why I was meaning that this is why you want to do this for your analysis. All right, so let's move on. So here I'm going to click on my ellipse, click on my population here, create a scatter gate, go there, do a gate over CD3. I'm not going to call these T cells, contrary to most common naming, because in CD3 positive cells, you also have NKTs and you have T cells. So if I label this as T cells, that would be incorrect. All right, so CD3 positive, and then I'm going to label this as CD4 against 8, because we're looking at HIV, right? So that's your standard look at. Okay, so now that we're here, what are we going to do? I'm going to go over the quadrant question that I was also asked earlier. And then after that, I'm going to go over scaling. After scaling, I'm going to go over the different visualizations we have. After that, I'm going to go over how to generate a gate that automatically locates your cells. So a little bit of auto gating. So, okay, now I mentioned about the quad gate. This is what you mostly see in a lot of papers, your straight quadrant. That is actually not a good way to draw an analysis. Why? Remember when I talked about spread? So you could have your negative population, which is right here. If I actually went because of that, I would actually put it here maybe. You can see that I'm getting a little bit of these population. That some people would argue, oh my God, that's positive, especially if they're doing tetramer staining. When in reality, it's actually not. Because what spread is, you see this CD4 population, you see how wide it is in terms of the CD8 axis? That's what I mean with spread. This should have been a lot tighter. So the brighter your samples are, the wider they're going to be. So that's why you need to be careful about spread, because then you could be thinking that something is positive, especially if you're looking at intracellular cytokines or you're doing tetramer staining or a low expressor, like you did stimulation of something and you only see a rare few events. Also, it's an issue with rare subpopulations. So what would I do instead? Because you may say, hey, Christian, you pointed out the issue, but you didn't tell us a solution. So what I would use is this quadrant. Oops, right here, my curly quads. You can see that instead of being a straight quadrant, it actually undulates upwards and to the right. That's to take into account spread. We've actually done the math behind this to estimate a best possible estimation of how do we take into account spread when we set it based on our negative control. So you can now see, before when I was detecting this as positive, when I was being stringent with this population, I put it right here. Now, it's no longer taking into account those events here that we saw earlier as positive, because the curly gates now recognize this for what they are, the result of spread. So this is the actual analysis you would be doing if you're doing a quadrant gate. All right, so in case you don't want to do quadrant gates, let's do other visualizations and how to do gating with that. Under options, this is pseudo color. Pseudo color is using color to look at density, where red is the most dense, blue is the least. We also have contours, which are some of my favorite to distinguish populations. So here, you're able to see when something is due to also spread that is not going to a different population. This whole population here in their CD4, you know, that's just one pop. However, when you look at CD8, you could clearly see the difference. It's separating into a dim population. So you're able to reveal this information when you use contour plots. So I would encourage you when you're doing your analysis to do a mixture between pseudo color and contours. You're able to change the percentage level by clicking on this drop-down menu. Next is density plot. This is just black and white pseudo color. Next is zebra, which is a hybrid of pseudo color and density. And you have your dot plot, which is not looking at anything except your events, and your histogram. I will stick away from histogram unless you're doing a cell cycle analysis or once you're doing your graphic reporting, but I would not do it as part of an analysis. Why? You are removing dimensions from your analysis, therefore making your analysis far too simplistic when you have more data available to you. Okay, so let's go back to pseudo color. Now that we covered that, I'll mention we were going to be looking at scaling. I'm going to create a gate so we can see how FlowJo does scaling. I'm only going to do CD8 right now because there's a reason why I'm not doing CD4. The next thing I'm going to do is click, well, also before I do that, you'll see that there's a lot of empty space, right? Or if you did this and they were way too bright, they might be at the edges. So we all seen data like that. You're like, hey, my population's on the positive edge or on the negative edge. Can I just gate on those? The answer is no, because you don't know what's up there. You need to see the data in order for you to gate on it. If it's against the edges, you can't do it, okay? So then click on the T button, click on Customize Axes. Here, there's your empty space. So just go ahead and click minus and click on Apply. Please pay attention to this, our graph. So I'm gonna click OK. You see now that it moved everything a little bit to the right because it reduced the number of decades you were viewing. Also, you'll notice that it made our rectangle gate wider. Why? Because you're not manipulating the data. You're just zooming in or zooming out. That's why I wanted to create that gate so you could visually see that I am not doing some kind of weird thing to your data or that you're going to be doing weird things to your data. Okay. Now, this is how you see some of those gorgeous figures where everything is perfect in the axis. You just basically zoom in or zoom out. Then the next thing I told you was to do how to do a little bit of autogating. That's going to be done with our feature of magnetic gates. So I'm going to create a little polygon here, like so. Label that CD4. Then under active gate, click on that. And then there's this button called magnetic. Click on that, and you'll see that it automatically reshifted the gate because it puts your gate based on density. So if you were running tens or hundreds of samples, that way you're not like moving the gate a little bit to the left, a little bit to the right, or a little bit to the top, or a little bit to the bottom. That's way too time consuming. Create one gate, name it magnetic. The rest of your samples will automatically have the gate located based on the cells. And now you have saved several hours worth of work. All right, yes? I personally never do quadrant gating because, or curly quadrants. One, if I need to do that, then it means that I need to do with high parameter. Because otherwise I could do other analysis with 2 gates or 1 gate. Or I could also do it with Boolean gates, and I'm going to cover that in a couple minutes. And it's far better than doing the quadrants. No problem. All right, so having said that, let's move on to how do you look at MFI, fluorescent mean intensity? How do you generate statistics off of that? And then also how do you do Boolean gating? So that way you don't have to do quadrant gating and you're able to analyze multiple parameters simultaneously in a matter of seconds. So I'm going to click on the CD8. And then I'm going to click on interferon gamma. All right. So we're looking at degranulation. Pardon, cytokine production. So here, what I'm going to do is just create a gate here. So what does this mean? Does it mean that if I generated an MFI here, I would have my MFI of interferon gamma positive cells? The answer is no. So I see, unfortunately, a lot of people that are new to flow that they make this mistake. Okay, all this is telling you is how many of your CD8 cells are positive for interferon gamma. That's it. If you want to learn the MFI of interferon gamma positive cells, you need to go into the interferon gamma positive cells by double clicking on them. And then what you're going to do is click on statistics, click on the sigma button, click on median, and then select interferon gamma. Click on add. Now, the MFI for your gamma positive cells is 6,732. How do we know? How can we confirm that? Well, 10 to the third is 1,000. 10 to the fourth is 7,000. So it's somewhere here in between, right? Your MFI. That is what MFI is. And that's, unfortunately, again, people that are new tend to do the prior gate, the parent gate of this, and call that the MFI. Next thing I want to clarify, MFI does not mean the mean intensity, mean fluorescence with calculating the mean. You actually calculate the median, okay? Why? Because you cannot calculate the mean of a log scale. That's just not mathematically correct. You use the median. You could also, if your heart is set on a mean, you can use the geometric mean, but not the regular mean. That's very important because unfortunately, again, I see a lot of people doing their Excel and they're nice on Excel spreadsheet and they calculate the mean. That's not what people refer to the MFI. Okay, so having said that, now let's move on to Boolean gating. So instead of me creating a gate on the 4 different parameters, right? Because remember the way that flow cytometry is. Flow cytometry is binomial. So 1 parameter is 10 to the first, 2 parameters 10 to the second, 4 parameters would be 10 to the fourth. That's how many gates you would need to do in order to get all the information for that sample. That is very time consuming and prone to user error. So how do you negate that and reduce the amount of labor? Select the parameter of interest. In this case, I just selected cytokine production. Next, I'm going to select degranulation. And again, I should be using an FMO to create these gates, but we're limited in time, so I'm not doing that. And this is not a real analysis, but you should be doing it with your FMOs. So degranulation, immunoactivation, so I'm just selecting the positive gates. That's all I'm doing. And phosphorylation. All right, now that I got them all selected, you'll see here, there's 1, 2, 3, and 4. All right, the next step you're gonna do is click under Tools and click on Create Combination Gates. Select OK. You're done. This is why I say not to use curly gates, because if you wanted to figure out which cells were positive for 2 parameters within your CD8 or CD4 subset, you could do this and actually find out all 4 parameters in a matter of seconds. So here you would see, for instance, this population is positive for immunoactivation, interferon gamma production, phosphorylation, and degranulation of a total of 2.1%. Yes? Oh, sure. The question was asked if I could repeat how to do Boolean gating for those of you online. So you click under Tools. Well, you select the parameter that you want to do your Boolean gate on. So in this case being these 4. Afterwards, you click under Tools and then click on Create Combination Gates. Yeah. So all Boolean gating is, it separates positive and negative and does circles that intertwine with each other and separates positive and negative. That's all it's doing. That's why we had to go in there and denote which were positive for this particular marker. I would use this if you're looking at characteristics of a subset. In this case, degranulation, activation, phosphorylation, and degranulation. I think I said that twice. But anyway, off of my CD8s. So go down to your major subset, then do Boolean gating for everything else. That's what I would recommend to do. All right, now that we did all this, it's a lot of work. So what I'm gonna do is go down here, select everything. And in FlowJo, we wanna save you time. So click, drag, and drop onto your group. And the analysis for all of your group is done, as you can see. So you just did an advanced conventional analysis. We probably did it in, I started like 5 minutes ago with this, and you're done. So you don't really need to invest a lot of time in analyses. Okay, so, well, conventional analysis. Now, now that we did this, we're gonna move on to the table editor, how to generate your statistics. And then I'm gonna get into the layout editor, and then we'll break for lunch. And this should be done in about 20 minutes. All right, so there's this grid up here, and that's our table editor. Click on that. And what we're gonna do is bring in what samples we want for our analyses. So I'm only gonna care about CD4. Let's say CD3, CD8, and interferon gamma and MFI, right? I'm not gonna do everything. So let me put this into the table editor, put down the microphone for a sec. All right, so I dragged it into the table editor. The next thing I'm gonna do is highlight all of them. Then click under visualize. Click the little fireball that's called heat map, because that's gonna make your analysis for stats a lot easier, trust me. And then you go back to the table editor and you click on create table. And this one gives you a very quick table that tells you in blue, which are low, in yellow, which are high for the different populations. Here, you could organize it as you like. So for instance, I wanna put it based on MFI. I just double click it and then it puts on descending order, right? Or you could double click it and it does in ascending order, whatever. Yeah, you could do that for whatever parameter you want. Now, if you want to send this to Excel, click under display, click onto file, the drop-down menu, click under, I would recommend to, when you click on Excel, select your destination and ensure that you're sending it to the right place. Here, we're just gonna keep it as table. Save, create table, you get that sound. And there's my spreadsheet and it has my Excel data now. So you could, that way you could take it to Prism. Also, just an FYI, we're working on our version 11. So most of the things you could do in Prism, you'll be able to do in FlowJo in terms of graphics and statistics. So that way you don't have to basically export to Excel. However, with versions 10 and lower, it is what it is, and we have to export to Excel to do more advanced stats.
I know you work closely with Josh to make the file and box plot plugin. That is a lot.
Yeah. Howie is talking about a plugin that we have that's a lot of stats for us. Some stats, does correlation plots. It also does some heat maps and it does some bar graphs, well, violin plots. But we'll get those to tomorrow. When we, I'm sorry, later today. I always forget. Yeah, the afternoon is the advanced session, not tomorrow. Sorry. Well, there is another one tomorrow too, but later today, and we'll cover that then. But if you wanted to do an ANOVA, a two-way ANOVA, a student t-test, or a viability test, those we cannot do yet. In version 11, we will be able to do those. Oh, no, Wilkin Cox as well. So I'm going to close this out. Go back to our table. We're done with our table. We're going to go to our layout editor. So that's this L looking thing on the top left. So if you click on that, again, I'm going to bring in the same population. Actually, here I'm going to include 4. Oops, hold on. All right, so I dragged those in there. I'm just going to delete 4 here. So you saw how I kind of messed up because I brought in an extra one that I did not necessarily want. So that gives us a good segue. So if I wanted to start clearing out my data, I'm going to click on Arrange, select all my samples, and then I'm going to say, hey, this doesn't look right, right? It's everything is off kilt. So I'm going to click on top. That puts everybody on the same level. And then I'm going to click on spacing to have the same spacing between each other. That's how you quickly organize your data or your plots. After that, I actually want to look at interferon gamma, not at phosphorylation to interferon gamma, right? That's a non sequitur. So I'm going to double click on that panel. And I'm going to click on the x-axis and change it to interferon gamma. And that's how you change visualizations here. Or parameters, pardon, not visualizations, parameters. The next thing I'm going to do is, let's say that in the third one, I don't want a pseudo color. For analysis, now I actually want a histogram so I could do comparative analysis at the end. So I'm going to click down the drop-down menu and click on histogram. Click apply. And now I've changed the visualization. Let's do one more change. Having CD4, CD8 on our gates is redundant because it's already on our axes. How do I change that, right? Because you may want to do that for publication purposes. Every journal is different. Some of them will ask you to include your parameter. Some of them will say to only include the marker, the biomarker. So be careful, read the suggestions for your journal, and then this is how you basically edit it in FlowJo to meet those criteria. Double click on it, click on annotate. On the label, for x-axis, I'm going to put CD4, CD8. This is also very useful if you're going to go to a conference and you have discovered a new parameter, a new biomarker, or you're working with a compound you don't want, you're not ready to release yet, you could label it as X, okay? So click on OK. Now you have 4 and 8. And if I double click on it, I could also remove the population names. And now it's just the percentages. So this looks a lot better than what I had originally. Okay, now I'm ready to generate a report. I'm going to go to File, go to Layout Editor. And then what I'm going to say, let's move our controls a little bit. All right, I just want one column. And I wanted to create a new layout editor to include all my samples. So I click on Create Batch Report. And the 4 samples within that group are done. Also, if you notice, the gate automatically moves, right? So this one on the very top is against the edge. And let me zoom in so you can see that more clearly. Oops, that's way too zoomed in. You can see right there, this one with the CD4, that's our magnetic gate, how it's against the edges. And if you go down, you'll see how in this example, in this sample, the gate has moved This is what I mean that it does. It shifts the gate automatically for you. You don't have to worry about it. All right, so that's how you generate that report. I'm not a huge fan of this type of analysis because it lacks information. So what I generally like to do, if my actual panel of interest is this, the interferon gamma, I would recommend you right-click, click on duplicate, and then go to the first one, right-click, and then click on ancestry. And this will tell the viewer all the parameters that were used to get there, okay, along with the gates. Next, on the second replicate, I right-click, and then I'm going to click on backgating. This gives you more information because it tells you if your analysis is correct with doublets. Also, if you're looking at cytokines like we are now, whether they're present in a different population, therefore giving you new ideas of new subsets to investigate, i.e. a new project or a new grant. So right now, this one is the non-stimulated. So nothing exciting is happening. But just you watch if I click on create batch reports. Let's go down to the very bottom. And I know this from prior experience that PMA ionomycin not only activates CD3, and this actually confirms that. So we had just done the prior analysis, we would never have known that this other population that's CD3 negative is also activated and producing interferon gamma. Like I said, we would not have known. But now I know that I could pursue this in a new panel, right? Looking for CD3 negative cells. Or I could even do it within this analysis. I could just create a gate over CD3 and look for the parameters I have. Although most likely I would need a new panel because I would need to look for monocytes or NK cells, etc. But this is far more valuable than if I just did 3 panels showing my 3, 8 interferon gamma, right? So, okay, so first part, that's looking at a very in-depth analysis per sample. Next, the question is not, okay, so what happens per sample? But the real question is, although it's important, how do the cells differ upon stimulation, non-stimulation? So I'm going to click on the create a new layout editor, and we're going to do a comparative analysis. So I'm going to click on interferon gamma, go on edit, and select equivalent nodes. What does that do? It automatically selects all my interferon gamma positive populations within my 4 samples, as you can see. They're already highlighted. Then I'm going to drag those into the layout editor. All right, so we have this here. The next thing I'm going to do is what we call an overlay. I'm going to highlight these. I'm going to highlight 3 samples. Okay. Drag it on top of the first one. And the first one, as you can see, turns blue. Okay. Let it go. Now you have 4 samples in this analysis altogether. You still can't tell much with it. So we need to do a little bit more work. Double click it, specify, click on type, change your visualization to histogram. And then we're going to change our axes to the modal because we want to normalize our comparative analysis, not on absolute cell number, but rather on relative measurements to each other. Otherwise, it's not a correct analysis. Because otherwise it'd be skewed based on who got more cells versus the other. So then you're going to click on OK. And now look at this. Now you could truly see how interferon gamma is affected by the different stimulation conditions. This is still a little hard to see. So what I'm going to do right click on it, click on histograms, and then do a stagger offset. This is much easier to see. So this would be a lot more valuable than a prior gate where you're like telling people, hey, look at 5 different plots in 5 different locations and try to tell it apart. This is exactly showing you where everything lies. And here you could start organizing it as you please. Usually I put my positives in the back. Oops. And you could just do that like that. All right. You could also change the colors, like you could tell in your paper that you're going to denote the positive control as black and say how everything looks elsewise. The other beautiful part of this, and I showed you already how to do the batch analysis, so I'm not going to do it all over again, is that if you open up this, double click on the table, you could designate a sample as a control. So if you're looking at different groups and you designate one sample as a control, it's going to do this comparative analysis against all your other groups. So if you were doing a longitudinal analysis, and within the longitudinal, you want to do comparative, then this is how you would do that. It will save you so much time. Your data will be so much clearer, and you're going to be able to get your point across. Lastly, I want to show you that we took the time to add in keywords and stats, right? So let's add that to our table. Add keyword. So we were talking about the STEM condition, and we also created our own, the vaccination keyword. Oops. Click on OK. Click apply. There are your keywords, your STEM and vaccination. Next, we added the stats for MFI. So click on median, click on interferon gamma, click on add, click on OK. And now there's your MFIs. And you could also then order it based on MFI. So you have all the information for your reader to view without you having to be referring to a bunch of different places. Now, one last thing, and I promise then we're done, is I want to show you how to generate the first figure for a paper when you're doing a complicated panel. And that way you could tell everyone, like, this is my gating analysis. Because I've seen some really weird things when people publish. But so I really like this plugin. We're going to click on, let's say, singlets, scatter, 3, 8, interferon gamma. Okay, so that's my gating, and let's say that this is what I want to show people, that this is what they need to focus on. I'm going to go to workspace, click on plugins, and then I'm going to click on, here it is. Yes, we're going to click on mist, and we're going to say, yes, look at everyone. Because we want to see what things look like, but only on the compensated. Since I use singlets. Oh, sorry, I was supposed to click on the parent, not the down sample. So this might be a little screwy. But if I click on mist, recalculate, still gets the point across of what I was trying to tell you guys. So, all right, this looks backwards. Let's move it this way so it looks a little prettier. Okay, very quick way for me to show a reader what my gating strategy is. And the size of the circles refer to the amount of sample present. So I started with singlets, then I moved on to scatter, and then I did a CD3 gate. That CD3 gate is bifurcated into 8 and 4s. And then my CD8, I did a Boolean gating analysis of things that were positive for these 4 markers and things and populations that were negative for those 4 markers. If I want to exclude the negatives, I could have just unchecked when I was doing the selection markers of the mist. This is super simple that you don't need to be a flow cytometrist to understand what you did. And this is why I mean this is your figure 1 or 1A of your paper when you're talking in terms of your gating strategy. Or if you're presenting it in the lab, right? Even if your colleagues or lab mates are not very versed in flow cytometry, they'll get this. So and I'll show you just one other trick since we have 1 minute left. This is also a really cool one. If you're doing a live demo of your work, or if you're able to add animations. I will recommend this one if you're going to a conference. People really enjoy this. You click on, again, workspace, plugins, and go to Sunburst. Just click on launch. Yes, again, I should have clicked on the parent, not this. I always forget. And then it gives you this dynamic figure where it shows you how things are sliced up in the pie in terms of percentages and values. So if I don't care about singlets, and people were like, well, what's under there? That's all tiny. Well, actually, I could go into my CD3 and open that by clicking on it, and then it's interactive. It closes everything under CD3, and it just shows everything that is belonging to CD3. So now you see that the majority is CD8, about a little over 50%, and you have a little under 20, well, it's like 28, 30% CD4, and then you have things that are double negative that I didn't create a gate for. And then you have under CD8, all the other populations. And you could also hover over them to get the absolute value. If you want to take this as a picture, you could just download it as a PNG, or you could incorporate this when you're doing your presentation, especially if you're doing like a lab meeting or a conference, then you could interact with this. That way you could tell your viewers what you're looking at. All right, so that's all I have today for your basic analysis. And in the afternoon, we'll come back and we'll go over high dimensional data and how to do analyses incorporating non-conventional into conventional parameters. Okay, thank you so much for joining us today. I'm going to talk with the basket.